Hey lads, I hope you're all keeping well. This is for Thursday the 16th, lecture 4, week 3. So the lecture I sent you on Wednesday would have actually been a recording from the previous module, which is lecture 5. It's called lecture 5, week 3. Very same content as what you would have been covering in, if I had recorded it again. So I'm recording this lecture now, lecture 4, and then I'll be doing lecture 6 for you on Friday. Just a couple of little things I wanted to get through before we make a start here. Regards your CBA 1. Okay, so CBA 1 is the first assessment that's going to be coming up shortly. We're going to be having a quick look at it now during this lecture. The other thing I want to talk a little bit about is our MCQs. Okay, so there was an MCQ was due this Sunday, week 4. I pushed that out to week 5. Okay, so I can't move anything. I'm not going to be moving the application principles. That's very manageable to get done in your labs this week. Week 5, however, I'm going to move that MCQ out. It just gives people a chance, and then as well as that, chatting with the TAs, your application principles. So just looking at the calendar here, we have it that it's just due on say a Sunday evening, but we're going to work it in a way now that you actually just get to have it ready for your next lab. So if you had your lab on Friday, you don't need it ready till next Friday. Alright, so let's just take a bit of pressure off you that way. And then the MCQ is still going to be on week 5, and I believe what we've decided to do is give 20 minutes at the end of your lab to complete the MCQ, so everybody will be able to complete the MCQ next week during their lab time, and that's how we're going to work all our MCQs, just to take a bit of pressure off people. It's not fair having it on a Sunday or anything like that. Okay, so with that, we're going to keep going through this now. So recapping on what we have, already. Sorry, Ireland's history of wood. We know about this. So we said at one point we had greater than 90% tree coverage. I started down as 1%, and now we're back up as high as 11%. Okay, we know that we're growing mainly a monoculture forest here in Ireland at the minute, and it's something that we are looking to hopefully change. And there is companies out there working towards improving the ecosystems of our forestry to try and improve wildlife and improve just our general land quality and health. So silviculture. We've talked about prescriptions and significant variables, determining the plan, carrying out plan and reforestation. So there's a lot of stuff within silviculture that you can dive deeper into, and we have looked at a good bit of it. What we're talking about today is going to directly relate to silviculture, and it's going to directly relate to our planning in the future, as well as the prescriptions that you'd have to prescribe. Case study. We had a look at our TED Talk, ecological and social benefits of reforestation, growth of forests, so measuring growth of trees, acquisition of data, and use of data. So these are kind of things we're going to dive back into again today. How it's actually gathered and why we need to gather that data is useful as well. Alright. So your application principles 1, which is due in this week's lab. So your problem scenario. Ireland has been subjected to significant deforestation for centuries. Recently there has been much effort directed towards the reforestation of land in form of grant aid and funding. You've been given the funding to reforest a 2-hectare lowland area in the Midlands of Ireland. Obviously you should be highlighting the things you think are important in this statement. You've been given funding to reforest a 2-hectare lowland area in the Midlands of Ireland. This area just outside of town with a population of 6,000 people. Explain how you would approach preparing the land for reforestation. Name and justify the selection of tree species you wish to plant in the area. What will the forest stand consist of, basically? Okay. Consider the whole life of the forest and outline how it can benefit the locality socially and ecologically. Refer to another example where reforestation of land served as social and ecological good. Your output for this, which is the important part. Communicate your solution using one A4 page and submit it as a PDF. Okay, you can use sketches, image, text. You could use PowerPoints, put in slides. You could use whatever you want. Whatever way you want to present this information, as long as it's on an A4 page, I'm happy with that. and as long as it can be submitted as a PDF so we can view it anywhere, you know. Don't mind how you submit it. It's important, however, that it's well presented. Okay, this is not a 10-minute activity. This is an activity that's worth some percent for you. Okay, so you really need to be on the ball with this and actually put the effort into it. Okay. Anything in particular I want to talk about for this? Look, it's all in the statement. I think you'll be okay. There's a lot of things you've looked at already, things you can talk about. One thing I do want to draw your attention to is the Quilcha diagram that we were looking at the last day. This diagram here. So things you need to consider for your case study. So this diagram, how Quilcha say they actually manage their forestry and what forestry does for people. Okay, so there's very little written on this. We've got planting, we've got growing, we've got managing, and we've got harvesting. Okay, so just think about this. You've planted these 2 hectares outside a small village, or a big village, whatever you want to look at it. What benefits are going to have? How many years is it going to take for the trees to grow into something that's enjoyable to walk around? Or is there anything else in that particular area? Is there wildlife? Will the species of tree you plant bring more wildlife to the area? Are you going to incorporate paths and walkways now while there's no forestry in the way? Plant your forestry around it? Are you incorporating picnic areas? What type of things can actually be done here? Or are you literally going to just go in there and plant 2 hectares of trees with the sole purpose of harvesting that material to, you know, create revenue for your own company? You know, like what are the benefits to this, and how are you actually selling this to the people of the village? You know, it's only just outside the village, so there should be more work going into planning this than, you know, just revenue being your main output. Just think of it as think of this as a A4 sheet, as something you might see maybe as you walk in the door, or walk in the gate of this new forestry plantation, or as you walk in the door of the community centre in the village or the town. Like, what's going to happen? What are people learning from this? What's being planted? Kind of like a little bit of an infograph, which I'm sure some of you have seen. Alright, so important species and their names. So I don't need to go down through all this. Just something that you might take an interest in is the different species and their Latin names. Okay, so gymnosperms are softwoods, angiosperms are hardwoods. If we look at what I've given you here, are kind of some main species or common species for each one. So Scots pine, noble birch, Scots pine, noble fir, Sitka spruce, Douglas fir, European larch. Look, I won't be trying to pronounce them for you. There's no real need to try and pronounce them for you, but it might be useful for your infograph, or might be useful for you to have as labels for trees in the future, things that are interesting about it. You can actually break down all these names and kind of get an understanding as to where the words came from and where the names came from. Angiosperms and hardwoods, we've got ash, beech, birch, oak, sycamore, and cherry. What are the common things between angiosperms and gymnosperms? This could be something that some of you might have included on your Google Sites the first day when you went and looked at the different species of trees, and you got a coniferous tree and you got a deciduous tree, and you tried to tell me which was which, and you tried to tell us the information about each one, what you knew, what you could figure out from that specific species. You might have talked about gymnosperms and how they carry their seeds, or how they're born in a cone shape. You might have talked about the scales. You might have talked about how the cone opens up when the seed is ready for growth, or when the weather starts to improve. The angiosperms, then you might have talked about the fact that it's usually a fruit, or starts off as a flower, turns into a fruit, and the seeds are born within that particular piece of fruit. So an example, an apple, seeds are inside the apple. The flesh of the apple is the fruit, and it can act as food to attract animals to help spread the seeds. It can also act as a fertilizer for the initial growth period of the seed. So there's different things, and the 2 different plants or 2 different trees actually carry their seeds completely differently and protect them in different ways. You know, it's not all about attracting animals, especially when it comes to gymnosperms. Gymnosperms are very commonly would use wind dispersal, or sometimes like an impact dispersal. When it hits the ground, they'll bounce out of the pine cone. So there's different ways of looking at that. So it's just thought it'd be something that I was hoping was going to be seen on a couple of the slides. something similar to this at the beginning, or the Google Sites at the beginning on our first assignment, and not a lot of people included it. Look, I didn't give you the guideline for it, which is understandable. I just want to see how far you were going to go into researching it. So just letting you know for the future, a little bit more depth for some things. Okay, so silviculture. So Silvi is forest culture is growing, yeah? So growth is clearly a significant aspect of silviculture. Normal growth follows a generic pattern, okay? So if we're looking at normal growth rates and we're following it along this graph, okay? A normal growth rate would be fairly consistent, okay? So we're not going to get a change, we're not going to get a drop. It's going to be a fairly consistent climb, especially for the first 15 to 20 years of the tree's growth, okay? We're going to get a consistent climb, and it may begin to plateau at a certain period when the trees have kind of reached their maturity, but in general, it's going to begin to climb. It's going to begin to climb rapidly, and then it will plateau. The growth rate will not decrease, it will continue to grow, but it may plateau or even, you know, slow down, okay? So if we take a closer look now, we're going to look at a few bits here. So normal growth, all right? So have a look at the graph. Let's see what we can find, okay? So if we're looking for total growth, we can work it out way down through this. So total growth, this is a consistent growth of the tree, so all aspects included, total growth. We're climbing at a steady rate. This might be between 15 to 20 years. It's at its fastest growth rate. Then it starts to slow down and will continue to grow. However, the growth rate decreases and time will obviously keep going on. Okay, so we begin to get like a plateau effect. However, it won't plateau completely until the tree actually dies itself. Okay, if we're looking here at the different types of growth here, then so we look at mean annual growth. Mean annual growth is the intersection of the current. Mean annual growth. Which one are we looking at? So mean annual growth is the average for the year. Current annual growth, and then relative growth. Okay, so relative growth is how fast it grows over the period of time. It's not really important for the minute. And then intersection of current and mean annual growth. Right. So growth model. Consider the impact of the following on this model. Okay, so tree species, seed quality, soil type, climate, and natural disasters. So this graph is based around the ideal growing conditions for a species of trees, any particular species. So just say, for example, Sitka spruce, because it's what we see commonly in Ireland. Okay, so if this is your total growth, this dark heavy line here in the center, that's your total growth. You've got a lovely, perfect soil sample, perfect tree, no damage to it. The soil quality is good, the seed quality is good, the climate suits the specific species of tree, and there's no natural disasters that occur during the life cycle of the tree. Okay, so tree species suits the area, perfect. It's growing very well, very consistently. Seed quality, the seed was of good quality, it struck well, and it grew a healthy tree. It hasn't grown a damaged tree, it hasn't grown something that's twisted, hasn't grown a small plant. It has grown a nice, good quality tree from a good quality seed. Soil type, the soil type suits the tree from what it needs. So is there enough minerals in the ground? Is there enough water in the ground? Think about these things in the mindset of applying a prescription into the area. Is the soil too wet? Does it need to be drained? Does there need to be more water added to the area? Climate, does that suit the specific species of trees? Yes. Also, how can the climate affect the growth? Are we in one end or the extreme climates? Is it a very dry climate? Is it a very wet climate? Or a very cold climate? Can that affect the growth rate? Yes, it can slow the growth rate a lot, so very, very significantly. Climate then suits it. Natural disasters. If we were to think about natural disasters, think about typhoons or anything like that that's happening now in the world at the minute, forest fires. It will not continue on. It'll continue growing to a certain point, and then there will be just an end. Yeah, it's not going to continue on for 90 years or 80 or 100 years, whatever the growth cycle of a tree is. It could end. It's going to end as soon as this fire or whatever starts, and it will just plateau. It'll flatline. Yeah, it'll stay at the same growth, same height, for the period of time until the tree has been removed. All right. So how is growth measured? Alright, so we've talked a little bit about dendrochronology, or we've looked at dendrochronology before. You've probably seen it before at junior cycle. But now what we're talking about is how the growth of a tree is measured during its life cycle. So we're not looking at harvesting the tree and measuring how old it was. We want to get the growth of the tree while it's actually alive. So there's a couple of reasons this is important, a couple of things we can do about it. If we're looking at it from the mindset of a prescription, we can take soil samples, we can have a look at the environment, we can look at the drainage of the soil. Then by taking measurements of the trees and getting an understanding of the growth of the tree, we can come to a conclusion whether or not that soil type is good for that type of tree. Is that tree growing well in this area? Do we have to look at this a little bit more detail and find out what has to be done to improve the growth of the tree? Is the tree going too fast? Is it going too slow? All that type of stuff coming from the area, right? As well as that, if you're looking to possibly harvest this timber, by doing these very simple calculations, you'll be able to actually make an estimate as to how much material can be harvested from each tree. So what are the cubic meters of material you're going to have from each tree, alright? So in regards to revenue, that's important. You don't want to harvest them too early, you don't want to harvest them too late. Too late, they get a little bit too hard to move around, too big, too awkward. Quality of timber can actually change then as it gets older. And as well as that, if they're too small, you've missed out on the peak period of harvesting, you know. So the first thing we need to do is get the DBH, so the diameter of the tree at breast height. So obviously everybody's breast height is a different height. So what we say is we measure 1.3 meters from the ground level or the root collar, whichever is higher, okay? So ground level is defined as where the stem meets the ground. Okay, so even if we're on a slope, or well, if the tree is on a slope, or if we're on a slope, we have to still consider that it's 1.3 meters from the root collar, all right, or from the ground. So if the tree is leaning at the slope, you measure from the shortest side. If the ground is at a slope, also measure from the shortest side. Yeah, you're looking for 1.3 meters, then you're going to get the diameter at that height. What about deformations or forks in the tree? Things can change in the trees. Not all the trees are going to be, easily harvested or easily measured. Not everything is uniform all the time, especially if we're working with angiosperms or hardwood trees. So if we're looking at the DBH there in the first image, figure 7, they're looking to measure the DBH at the 1.3 mark, and there's obviously some sort of a growth on the tree, so a burr or a large piece of damage on the tree that's been grown over with the bark. And they've looked at it and said, well, that's not a true reading of the tree or a true reading of the material thickness. However, just below that seems a bit more consistent, so they keep it as close to the 1.3 as they possibly can. All right. Same then when it comes to figure 8, and we're looking at a Y in the tree or a fork in the tree. They come to their 1.3 and they measure both stems. If the fork measure both stems, if the fork is below the 1.3. If the fork is above 1.3, you still just measure your 1.3. That's part of it. That's just how it works. Yeah, because at some point going up the tree is going to break into maybe possible stems or branches. Again, depending on the species. And then figure 9 shows to measure at the narrowest point below 1.3, the fork is at 1.3. So if the fork comes to at exactly 1.3, we need to measure at the narrowest point. We'll understand that if we think about what we see in forestry and what we see in trees. Quite often the tree can bulk up as it comes to a fork in the tree, where it's starting to divide, which again wouldn't give you a true or accurate reading. So you're going to come down to the narrowest point below the forks to get a more accurate reading of the quantity of material within that specific tree. Now, so we have the DBH, so our depth or diameter of breast height. The next thing you need to do is get your height. Okay, so it's hard to get the height of a tree, or to imagine getting the height of a tree if ideally you just want to lie it down and measure it. You can't do that unless you're following the tree. We don't always want to do that. We want to get measurements of trees where the tree is still growing and alive, and get estimates of materials, or just, for example, we're trying to understand it ourselves. So this actually might be an activity we can take part in again this year. You could make your own acclimeter. using just a protractor and a piece of string, as far as I remember. So I might get that back out and try and get used to do that in the lab, and try and measure the height of a couple of trees around. Just a couple of very kind of trees of legacy, as they would call them, around UL. So you might be able to take a couple of measurements of some important species. So there's measurement tools for trees are a hypsometer, okay. So we're looking for total height of the tree. So again, coming from the stem of the root, okay, or the ground height. Yeah. So where you would have measured up your 1.3, you're looking to get the total height of the tree. So from that point all the way up, okay. So there's different ways of calculating this, and if you're any good at maths, or you should have no problem kind of doing these sort of calculations. All right. So basically, you're going to take the height of the tree by measuring back a certain distance. This piece of equipment here, the Forestry Pro, the way this works is it calculates your height off the ground, so the height you're looking at the tree from. It measures how far away you are from the tree, and then it will calculate the angle from your eye level to the top of the tree that you've looked up at, and then to the root system of the tree where you've looked down to. And it gives you two triangles, and then I think it'll use Pythagoras theorem and basically give you the total height of the tree. We can actually calculate this ourselves, and it's something that I think we will look into and possibly do as a lab activity in the future. Once you have your diameter of breast height, and you have the height of the tree, and you know the species of the tree, because this is important, the species of the tree will obviously affect the cubic volume of material within the tree. Yeah, so we need to be kind of conscious of the species. Sometimes we have to actually be conscious of the soil types and the growth rates of it. Is that tree an accurate representation of, say, the mean tree or an average tree of that particular species? Has it grown extremely well or extremely poorly in different locations? Is this going to be an accurate calculation as to material quantity and material quality of the area? This can vary, and it's something that you need to know. How do you know if this is an average tree? You will be able to look up the data. You'll be able to work your way down through the sheet and see, okay, my tree is roughly this age, and you'll be able to have a look at it and go, it's fairly similar in diameter to a lot of these other trees here, so it must be fairly average. Or if it's below or above, you'll be able to understand then that your calculation is going to be off. Is going to, you're not going to be able to get an accurate reading, depending on what the soil type has done, or what soil type is like, and how it's affected the growth of the tree itself. But in general, diameter of the tree, height of the tree will give you a cubic meter. Alright. So the next thing we're looking at here is the scientific method. So it's not directly related to tree science and tree growth, but however, it is a method of thought or a way of thinking that, if you get the hang of it, it's not necessarily a step-by-step approach, but if you get the hang of this and you actually utilize this throughout your whole time in UL, it'll make your life a lot easier. Sometimes it'll make your TA's life a lot harder, but it will make your life a lot easier. It'll give you an opportunity to improve and question things and develop a more in-depth understanding or in-depth knowledge base on whatever module it is you're taking part in, be it graphics, be it woodwork, education, whatever. So it's a very simple diagram here, and it's something that you could print it out and stick it up on your wall in your room. These methods of thought, or this train of thought, is something that can be done over and over and over again for the same activity to help you get the most in-depth solution to solve any problem that we can. Okay, so if we're to talk about this and have a think about it in the format of a tree prescription of a stand, okay, so observations. What's the first thing you're seeing when you walk into a stand? So if you walk into a specific stand, you're looking at it, you're taking notes. Observations, you're not making any accusations, you're not assuming anything. You're literally going in, taking your measurements, observing what you see, making notes about it. At a later point then, you're going to make questions, and you're going to start to think and talk about, why is this happening? Why is that tree that size? Why is the ground very wet in this area? Why have I seen, a lack of new growth coming on the branches in this particular corner of the site or the stand. You know, search for literature. So no matter how much experience you have, you'll always have to search for literature. You'll have always to find external information to help you understand what you see, either be it a problem or be it a time when the tree itself is actually outgrown or done better than it should have done in the area, and you're surprised by it. But you still have to find this. You will still have to find this literature to get an understanding of it. From that understanding, then you can create a hypothesis as to what's going on. You can try and figure out how you might solve it. You might try then come up with a couple of experiments, and see how the solutions come. That first experiment might not necessarily give you the answer, but you're going to collect your data from it. What is the benefit of collecting data? Your observations, you've collected data. You've done literature, you've collected data. You've created a hypothesis, you've done an experiment, you've collected data. Okay, observations directly from the site. Literature is data based around the site, and based around the issue. Collection of data from your experiment, directly related to your site. Conclusions. What have you learned from this data? What can you see? Share your results with peers, share your results with academics. See what we can do, see where their feedback comes back from. What other observations can people see that you might not necessarily have seen at this point, be it their experience or just a new lens looking at it. Develop interventions. So in our case, then a prescription. That would be a prescription. Develop that prescription. Apply the prescription to the stand, and then ask new questions. So give the prescription of the time to sit in for us. Most of the time, these things will be a little bit quicker, but we're obviously working with forestry and we can't rush it. So after we've applied a prescription, we start asking new questions. We start making more observations, and the cycle continues and continues and continues. It has to continue. If you don't stop, or if we do stop, you've assumed you've solved your problem. Life isn't like that. Trees aren't like that. Teaching's not like that. There's always a new challenge around the door, around the corner. There's always something that has to change, or something that you can improve, be it to make your life easier, make your quality of teaching better, improve the site quality or the stand quality in a forestry plantation. The scientific method is something that everybody needs to take care of and actually start looking at and pay a bit more attention to. Even when it comes down to laying out information on sheets regarding your application principles or your CBAs, this kind of step by step, what can you see, can be broken down into two or three very simple steps. Observations, literature, data about an experiment, share your results. It's not complicated when you look at it that way, but it's going to benefit you a lot in the future. So I just wanted to raise a flag for this for you, just to show you what you were going to need to look at. Okay, so again, thinking about the sites and stands. All right. So why is one of the most important questions anybody's going to ask you, and you're going to ask kids and you're going to ask people when you're out teaching. If someone can tell you the why is something, it means they actually understand it. So why measure growth of the trees? How does this information help the management of the forest? How can this help the future planning of forestation? And why is data important when dealing with forestation? How does the scientific method apply here, and how can it be used? So we talked about how the scientific method applies, and we talked about how we can use it not just in a forestry stand. We talked about how we can use it in our life in general, which is something I think is just as important, if not more important. Why is the data important when dealing with forestry? Data dealing with anything, not just forestry. So we could substitute forestry there for any word, anything. Hurling matches, football matches, cricket, whatever you want to talk about, vegetable growth, anything. If you don't have a good database or a good collection of knowledge from varied locations and varied academics or researchers, you can't create a balance. You can't create estimations. You can't just assume things are correct. You can't assume that your trees are growing very well if you don't have a database showing you the average growth rate of that particular species of trees in different locations at different times. It just can't be assumed that that's what's going to happen and that your things are working out well. By collecting data, you're able to actually make it a bit more accurate, and you're able to have a more accurate understanding and a more thorough estimation when it comes to material quantities, for example. And then how can it help with future planning of the forestry? So how can I help the future planning of the forestry? That is very self-explanatory when we start talking about scientific method and the stand. I've spoken about that for the last probably 2 or 3 minutes. Again, if you don't understand it, you haven't been able to dissect it and research, you haven't come up with an hypothesis. Without the scientific method, you're basically going to set yourself up for failure again if you haven't taken your time to try and understand the location, understand the trees and the forestry you're planting. It's not a season-long period of growth. It's a life cycle for us. It's a 40-50 year life cycle for the trees. You can't go at this half-heartedly. By paying the attention to your data and paying attention to the scientific method, forestry can be improved for the future and will improve the better growth period. Something I do hope people understand and I hope I see in their application of principles is on the A4 sheet is the effect of monocultures in the area and the effect monocultures have on our water sources and on wildlife in the areas as well. So something I want to see. Why measure trees? We've looked at why we measure trees. One of the main reasons we want to try and understand the growth of trees from a revenue point of view is how much material we can get from it. Another reason we'd like to measure trees as well, alongside possibly creating data or samples of soil samples, is to understand how well a species of trees grow in certain climates in certain soil types, so that in the future, if we did need to plant specific trees in certain areas, we'd have a good database and we can actually make that assumption then that this tree will grow well in this location, it will produce roughly this amount of timber after this amount of time, and we can create then a plan or a prescription for a site there and then. So what are the tree, well, sorry, not tree, we're looking at wood uses, okay? So this particular graph, very simple, very understandable, and it's important, especially when we start to talk about your CBA. Okay, CBA is something that we mentioned in the first lecture, and it's something that is going to be talked about a bit more in your labs, maybe if you get a chance. I will talk about it again in the next lecture. But regarding your CBA, I asked you to think a little bit about what you think wood is used for and what you can use it for at home. It was something I did say I needed you to pay attention to. And we're starting to dive back into that now. There will be a lab shortly where you just work on your CBA and get a good understanding of it. So, wood uses, the 3 big C's, alright? We've got construction, containers, and chairs. Yeah, so construction, containers with all your boxes, and then really furniture, okay? We've got fuel, and then luthiers. So luthiers are musical instruments, alright, people that make musical instruments. So there are main uses for timber. After that, you can branch off into any area you like. You know, you can go into construction, you can look at deckings, you can go into containers, you can look at jewellery boxes, chairs, you can go off and look at steam bent, laminated, whatever. There's all these different areas that these can go into, okay? But these particular areas are kind of the center stems of, say, your mind map. And from that point, you could explode and go into any particular location. And I'd like to hope that you have been thinking a little bit more about this and not just looked across the room and seen a hurley and thought, okay, a wooden object you see every day, hurl. You know, think a little bit more, because we want to start talking about properties. There's nothing wrong with a hurley. A hurley is a really good example. I actually have a CBA one CBA one from a second year last year. I'm going to be sharing it with you shortly. And he created his own hurley and he done experiments with them and tried to compare different materials and understand it. It's a very simple little project. Took him the 3 classes. The 3 weeks, but he learned a lot from it and he understands a lot about the material, so it's something we're going to talk about later on. Okay, so again, I'm just going to leave you with this application principle 1. So take your time, have a look at it, really focus on the outputs. It's important to get an in-depth understanding as to what we can do with forestry, not just from a revenue perspective. Okay, so what can you do to actually improve the well-being of the community? What can you do for the next 20 or 30 years before that forestry is harvested? It's not just a case of plant it, manage it, harvest it. It has been like that in the past. It has been like that. And if you think about forestry like this and places people see all that, there wouldn't necessarily be a very good opinion of that particular type of forestry. You know, if you're from any of these areas, you'll for your whole life cycle, your whole period of life up to now, you'll have driven down the same road and you'll have seen the same big forestry. You'll have realised it's very dark in houses around that forestry when it gets and still early in the evening. There'll be a lot of moisture in the air, and the water sources in the area can go very grey. All the little rivers will be full of silt, from our monocultures that we're growing at the minute. And then once it's harvested, all you'll hear is people talking about, oh, it's very dirty, it's very messy looking, like what has actually happened. They've harvested and clear-felled the entire side of a mountain that for the last 20 years or 30 years people have driven in and seen this, what they thought was a big forest, a lovely big forestry plantation. We need to try and sell this to people now. These forestry plantations have gone on in Ireland for so long now that not everybody would be a fan of them, as we say, and have seen the destructive side of it as well as the plantation and the growth period of the trees. And when people start to see the destruction and they think, I've seen this destruction in my local area, I don't want that eyesore, in their opinion, in my area. So let's kind of think about what can we change in this plantation, especially considering it's so close to local amenities and the community. How can we get more purpose from this? If there's a primary school only up the road, what can the kids do in this particular area that's going to make things better for them? Can we put in a small playground? Can we create nature walks around the forestry? Can we try and utilize native Irish trees to potentially bring in some native wildlife, so that when the students go on their nature walks, they can get an understanding of it? When they go to collect their nature table, they're not just going to all go around and pick up pine cones off Sitka spruce. We want them to see the variety. We want to see the different colours. We want people to develop an appreciation for forestry and the plantations. So there's a lot more to this application principle than just, let's plant a few of these trees here. They're gone grand. It's boggy land, not a bother. Think about this. And I'm really looking forward to seeing some of your outputs. Okay, so I will be recording the lecture for Friday, and I will be giving a slightly longer lecture on Friday as well, to try and catch up on some work that we might have missed out on. Again, you have access to all these lectures online. Please do listen to them. If you have any questions, email myself or the two TAs there. There's no problem at all, and we will get back to you. Okay, so thank you very much. Talk to you again.